Welcome back to another video. In this video, we're going to be going over the questions of the AMC8 2001 test, starting from problem 19. If you haven't watched the first two parts, make sure to watch it. It's linked in the descriptions below. Let's get into it. Problem 19. Car M traveled at constant speed for a given time. This is shown by the dashed line. Car N travels at speed for the same distance. If car N's speed and time are shown as solid line, which graph illustrates this? So first we're looking at n, and n has to be at a higher speed, so it has to be on top of m. So this cancels out c and e immediately. Next, since n is going twice as fast, it would have to only go half as much time. So the only one that matches that is d. If it went as much as a, then n would be twice as far as m, and if it went more than m, then it would be even further. But since they traveled for the same distance, it has to be d. Problem 20. Kalina shows her test scores to Quay, Marty, and Shanna, but the others keep their hidden. Quay thinks at least two of us have the same score. Marty thinks I didn't get the lowest score. Shanna thinks I didn't get the highest score. List the scores from lowest to highest for Marty, Quay, and Shanna. So, Quay thinks at least two of us have the same score. So Quay has the same score as Kalina, and thus he is in the middle. Next, Marty thinks I didn't get the lowest score. So he got a higher score than Kalina. So he is higher than Quay over here. And then Shanna thinks I didn't get the high score, meaning she got a lower score than Kalina. So she is over here, since you're going from lowest to highest. So our order is SQK, and oh wait, what am I doing? Not K, SQM. And so this is answer choice A. Problem 21. The mean of a set of 5 different positive integers is 15. The median is 18. The maximum possible value of the largest of these 5 integers is one of these. So these 5 numbers are like this. The median, or the middle one, is 18. And we'll just give the values A, B, C, and D like this. And we know that the average of these is 15, or the mean. That means if you add all these numbers up and divide by 5, you get 15. And then we can solve this in terms of A, B, and C, and D. So A plus B plus 18 plus C plus D is equal to 75. 75 minus 18 would, 18 would equal 60, 57, like this. And then since we want D to be the highest, we want to counteract this by making A, B, and C lower numbers, as low as possible. And since they have to be different and positive numbers, A has to be equal to 1, B has to be equal to 2, and C has to be equal to 19. And then now we can solve for D. And C has to be 19 because it has to be greater than 18, but it can't be 18 since it's 5 different positive integers. So then after adding all this, we get 22 plus D is equal to 57. Subtracting that, we get D is equal to 35. So our answer is D, 35. Next, problem 22. On a 20-question test, each correct answer is worth 5 points, each unanswered question is worth 1 point, and each incorrect answer is worth 0 points. Which of the following scores is not possible? So we can definitely get a 90 if we get 2 questions wrong. So that would be 18 times 5, which is a 90. And if we got 2 questions wrong, that would just be plus 0, which is 90. And then we can get 91 too. 18 times 5 again equals 90, plus 1 plus 0. So 1 unattempted question and then 1 question wrong, which is equal, 91 over here. And then same thing for 92, 18 times 5, 90, and then 2 unattempted questions, which equal 92. And we can get a 95 too, which is a 19 times 5, meaning 19 questions right, and 1 wrong question, which would equal 95. but we can't get a 97 because the next greatest we can get is a 96, which would be 19 times 5, which equal 95 plus 1, unanswered, which equal 96. And the next one after that would be a full 100. We can't get a 97, 98, or a 99. So the one not possible is E. Moving on, problem 23. Points R, S, T, R, S, and T are vertices of an equilateral triangle, and points Y, X, and Z are midpoints of these sides. How many non-congruent triangles can be drawn using any 3 of these 6 points? So obviously we can make the triangle SRT and SYZ. So those are the two most obvious triangles. And let me just give a tally over here. And since they have to be non-congruent, we can't just make other triangles like YRX. We have to make new types of triangles. And another triangle would be SRZ, with a base of 2 and then a height of about that much. And other iterations of the same thing would be like this. We can't count that again. So that's one more triangle. And the last type of triangle is this one. And this again has a base of this and a height of this. This can be seen again over here like this and like this. These are just all iterations of the same triangle. So that would be the last one. So the answer is D, 4 triangles. Problem 24. Each half of this figure is composed of 3 red, 5 blue, and 8 white triangles. When the upper half is folded down over the center line, 2 pairs of red triangles coincide, as do 3 pairs of blue triangles. There are 2 red white pairs. How many white pairs coincide? Okay. So first let's go the 2 red coinciding pairs. So these 2 coincide and these 2 coincide. So that's 2 pairs. And then 3 blue coincide. So 1, 2, 1, 2, 1, 2. So those 3 pairs coincide. And then there are 2 red white pairs. And since there are only 3 on red on each side, we have to draw it like this. 1 red on one side, 1 red on the other side, which creates 2 red white pairs. And now the remaining are just not all white pairs because we still have some blue remaining. We only use 3 blue on each side. We still have 2 more. Well, since only 5 coincide, none of these are pairs. These are white blue pairs. So we'll just draw them across from each other. And overall, this takes up this much space on this side. Let me just color it in. What is this? Color it in. And this much space over here for these. So this is colored in, this is colored in, and this is colored in. And the only space left would be these triangles, 1, 2, 3, 4, 5. And then 1, 2, 3, 5. So the answer is B, 5. Moving on to the last question, problem 25. There are 24 4-digit whole numbers that use each of the 4 digits 2, 4, 5, and 7 exactly once. Only one of these 4-digit numbers is a multiple of another one. Which is the following, is it? So this is going to be the greater number, and dividing this by some number will give us another number, which is a combination of these 4 digits, 2, 4, what is this, 4, 5, and 7. So to find this, we can try to find the number which leads to this answer, which leads to the other number. And since we know dividing, it has to be a 1-digit number, or else it would divide by too much and not create a 4-digit number. So this limits our range from not 0 even, not even 1, 2 to 9. And dividing the first number by any of these would make it 2 less and not let it start with a 2, 4, 5, or 7. So we can just cancel out A. And yeah, because if we divide by 2, it would lead to something like 2 and then something. So 5, 7, 2, 4 divided by 2, like that. and then 2, 4, 1, 7, 8, 16, 1, 2, 6, and then 2. So the answer would be 2, 8, 6, 2, which is obviously not a combination of 2, 4, 5, and 7. And again, if we divide by 3 or any other number after that, it would become too small. So 5, 7, 2, 4 divided by 3, it would start with 1, and that obviously doesn't work. So we can just stop over there. And then if you keep on dividing, it gets smaller and smaller, which won't work because we need to start with at least 2. So let's continue with the next ones. So in the next ones, if we divide by 2, we start with a 3, which is not going to work. So any of these divide by 2 would start with a 3, and 3 is not one of the 4 digits. So let's move on to the next number. So let's start with 3 now. And if we divide the second one, 7, 2, 4, 5, divide by 3, we get 2, 6, 12, 4, and then 45, and then 1, 5. So we see 1 is not a number, so this one doesn't work at all. So we can get rid of all this. And moving on to 7254. 7254. Divide by 3, 2, 6, 12, 4, 54, 1, 24, which would be 8. So again, 2, 4, 1, 8. This doesn't work at all, so we can get rid of this. And then moving on to D, 7, 4, 2, 5, divide by 3, 2, 6, 1, 4, and yeah, 4, 12, 2, 2, 7, 21, 15, which would be 5. And this happens to work, 2, 4, 7, 5, which is a combination of 2, 4, 5, 7. So this would be a valid answer, number D. And we didn't check any of the other numbers from 4 to 9 because dividing those would lead to the same thing as before. It would lead the number to start off with 1, and we need to start off with at least 2. So that's why we divided all those by 3, and our answer is D. Well, that wraps it up for this test and this video. Stay tuned for any upcoming videos, and have a great day.